Your thoughts are not just noise in your head. They might be interacting with the very fabric of existence in ways science is only beginning to explore. Not through magic, not through wishful thinking, but through legitimate questions being raised at the frontiers of physics and neuroscience. Today, you're stepping into a conversation that's been quietly stirring behind the scenes in labs, universities, and theoretical think tanks across the world. One that dares to ask, is consciousness more than just electrical activity in the brain? Could it have roots in quantum mechanics, the very same system that governs the behavior of particles smaller than atoms? Let's be very clear. This is not a pitch for pseudoscience. We're not dressing up mystical thinking in scientific language. We're unpacking the real, observable tensions between what physics tells us about reality and what subjective experience tells us about being alive. Consciousness remains one of the great unsolved puzzles of science. Despite all our technological advancements, nobody has a definitive answer to the most basic question. How does physical matter, neurons, synapses, chemicals, produce something as rich and layered as subjective experience? Now let's zoom in on the world of quantum physics. This is the domain where particles can exist in multiple states at once, where entangled particles seem to influence one another across vast distances instantaneously, where observing something changes what it does. It sounds bizarre because it is, but it's also real. It's how your phone works. It's how GPS functions. Now, here's where it gets interesting. Some researchers believe that consciousness may not just be a result of brain activity, but could instead be linked to quantum processes. That would mean the mind is not simply processing reality. It could be actively participating in it. This isn't a fringe idea anymore. There are now legitimate, peer-reviewed frameworks that explore how quantum theory might help explain the complexity and mystery of conscious awareness. These are not claims that thoughts control reality like a magic wand. These are inquiries into whether the weirdness of the quantum world is somehow tied to our ability to perceive, think, feel, and even choose. Throughout this video, we're going to explore 6 critical ideas that are helping to shape what some call quantum consciousness, but we'll do it without exaggeration or metaphysical fluff. We'll break down major theories, challenge assumptions, and hold each idea up to the light of real evidence. No buzzwords, no new age slogans, just big questions grounded in the pursuit of understanding. You'll come away with a clearer picture of what science actually says about the mind's place in the universe, and where the limits of our current knowledge end. Because the real power of this topic doesn't lie in offering answers. It lies in showing us just how little we truly know, and how much more there might be to discover. Let's start with one of the strangest and most provocative questions of them all. If a particle can exist in multiple places at once, can your mind do the same? There's a phenomenon in quantum physics known as superposition. It refers to a particle's ability to exist in multiple possible states simultaneously, until it's observed or measured. Think of it this way. Instead of being in this place or that place, the particle hovers in both possibilities at once. Now, here's where the comparison gets unsettling. Your thoughts, your inner experience, often seem to reflect multiple realities at once. You anticipate the future while recalling the past. You imagine one outcome while fearing another. It raises a provocative idea. Could your conscious experience be a kind of mental superposition? Let's pull this back to hard science. In the early 1990s, theoretical physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff introduced a hypothesis known as orchestrated objective reduction, or orchestroar. Their proposal that consciousness arises not from classical neural firing patterns, but from quantum processes occurring within microscopic structures in neurons called microtubules. These microtubules, they argued, could be small enough and sufficiently shielded to support quantum coherence, a condition required for superposition. If true, it would mean that consciousness is not just an emergent feature of brain chemistry, but a quantum event influenced by probabilistic, non-local rules. Here's why this is both intriguing and controversial. Most neuroscientists argue that the brain is too warm, too wet, and too noisy for delicate quantum processes to survive. Quantum coherence typically requires extreme isolation, Think of superconductors cooled to near absolute zero. How could similar phenomena occur inside living cells? Yet the orchestroar model gained traction when researchers began discovering that certain biological systems do exhibit quantum behavior. Photosynthesis in plants, the navigation of birds, and even the sense of smell have all been shown to rely on quantum coherence. So, the idea of quantum biology isn't science fiction. It's emerging science. But does that mean consciousness is quantum? Here's where things get cloudy. So far, there's no definitive evidence that quantum superposition occurs inside neurons in the way orchestroar proposes. Supporters argue that the scale and architecture of microtubules could support coherence for brief moments. Critics counter that no such coherence has ever been detected in the brain. Still, the theory has a strange resilience, partly because it offers a framework for something science has never fully explained: why consciousness feels unified, even though the brain is made of billions of separate firing cells. Quantum superposition could, in theory, explain how multiple possibilities are integrated into a single, flowing conscious experience. The many simultaneous mental states we navigate, hopes, regrets, plans, awareness of time, could resemble the parallel potentials of a quantum system, until a decision is made and the mental wave function collapses into one outcome. That's the seductive part. The part that feels like science is almost catching up to what experience has always suggested: that the mind is more than a calculator. It's a theater of potentials. Still, we must ask, is this explanation necessary? Many neuroscientists argue that complex information processing alone, without invoking quantum rules, is enough to account for consciousness. They claim that until quantum processes are directly observed in neural activity, the theory remains an interesting speculation. And that's the key. Speculation is not proof, but neither is dismissal. The idea that consciousness might rely on the strange logic of quantum mechanics forces science to keep asking better questions. What if the mind is not simply hosting multiple possibilities, but exists as a system of probabilities, always resolving, always collapsing into choices? Not metaphorically, literally. That's the open question. And it brings us to another quantum puzzle that touches even more directly on how we perceive and interact with the world. Is your consciousness changing reality just by observing it? That's where we go next. A photon passes through a tiny slit. It hits a detector on the other side. Simple enough, right? Now take millions of photons, one at a time, and send them through two slits. You'd expect them to pile up behind each slit like sand grains. But that's not what happens. Instead, a mysterious pattern appears on the detector screen. A series of alternating bright and dark bands. An interference pattern. The kind of thing you'd only expect from waves. Not particles. Not individual photons. So what's going on here? Welcome to the famous double-slit experiment. The experiment that shattered our assumptions about reality, because it revealed something profoundly unsettling. When you don't observe which slit a particle goes through, it behaves like a wave, exploring all possibilities. But the moment you observe it, track it, measure it, label it, it snaps into behaving like a particle. The wave of possibility collapses. Only one outcome remains. This raises a staggering question. Is reality fundamentally dependent on observation? Does consciousness, your awareness, actually influence the outcome of physical events? Before jumping to conclusions, let's clarify something. In physics, observation doesn't necessarily mean human attention. It refers to interaction with a measuring device, any kind of detector. So, in theory, no human brain is needed to collapse a wave function. It's the act of measurement, not the observer's awareness, that matters. But this distinction hasn't stopped thinkers, philosophers, physicists, psychologists, from pushing deeper, because there's still something weird happening. Something that challenges our common sense idea that the world exists out there, independently of what we do. In quantum mechanics, reality isn't fixed. It's probabilistic. It exists as a set of potential outcomes, until something forces it to choose. And even though standard interpretations don't demand consciousness to trigger that collapse, some interpretations do leave room for it. One of the most provocative is the von Neumann-Wigner interpretation. It proposes that consciousness itself might be what collapses the quantum wave function. In other words, it's not just the measuring device that matters. It's the presence of a conscious observer aware of the result. This idea is deeply controversial. Many physicists reject it, preferring decoherence models that explain wave function collapse through interactions with the environment. But even those models don't fully eliminate the mystery, because even if particles collapse through environmental interaction, there's still the issue of how and when outcomes become real. And that's where the mind re-enters the equation. Let's take a closer look. Your brain is made of particles. Your neurons, your thoughts, your memories, all built from quantum-scale components. So it's not just that you observe the world. You are part of the system. You are an observer made of the very stuff you're observing. And here's the twist. If observation affects reality at the quantum level, and your brain is a quantum system, then every time you make a choice, you may be participating in shaping what becomes real. Now let's ground this in more familiar territory. Take attention. When you focus your mind on a task, a decision, or a problem, you're not just perceiving, you're influencing outcomes. Not in a mystical sense, but in terms of neural plasticity, behavior, and feedback loops. Your choices, reinforced by attention, alter your experience. And your experience becomes your version of reality. So is the observer effect at play here? Not at the quantum particle level, but at the personal, cognitive level. Quite possibly. There's another layer worth exploring. Experiments in quantum cognition, a field that applies quantum models to decision-making and perception, have shown that human choices often reflect the logic of quantum probability. We don't always follow the neat, linear reasoning of classical models. Instead, we act as if we're navigating probability fields, where outcomes are entangled and choices interfere with one another. This doesn't mean the brain uses quantum mechanics in the same way atoms do. But it might mean that quantum models offer a better fit for understanding thought, uncertainty, and decision-making. And that could point to a deeper truth, that the mind and the quantum world speak a similar language of probabilities, interference, and collapse. So where does this leave us? Are your thoughts literally altering the universe? Not in the think it and it happens sense, but in a subtler, more profound way. When you pay attention to something, you assign it meaning. You encode it neurologically. You amplify it through action. In this sense, your awareness filters the infinite variables of life and collapses them into a stream of conscious experience. And at the very edges of physics, there's still no clear answer as to whether consciousness is a side effect of measurement or the cause. Even Nobel Prize-winning physicists like Eugene Wigner and John Wheeler took this idea seriously. Wheeler proposed the participatory universe, a model where reality is not just passively observed but co-created by observers. Does that mean your mind creates the cosmos? Not exactly, but it suggests that consciousness may be far more fundamental than previously assumed. It's not a ghost riding the machine. It may be part of the machinery itself. The observer effect teaches us that what we focus on isn't neutral, that the act of noticing has power. That awareness, yours, has an active role in shaping what becomes real, not by bending the rules of physics, but by aligning with them in ways we still don't fully understand. This brings us to another strange behavior in the quantum world, one that challenges everything we know about space, distance, and even individuality, because if particles can remain mysteriously linked across vast distances, the question becomes unavoidable. Can your mind do the same? That's where we go next. Two particles interact. Then they separate by inches, by miles, even by light years. And yet, when one is measured, the other responds instantly. Not seconds later. Not after a delay. Instantly. This is quantum entanglement, a phenomenon Einstein once dismissed as spooky action at a distance. He didn't like it. He believed in locality, the principle that nothing can influence something else faster than the speed of light. But experiments over the past few decades have proven it, again and again. Entangled particles behave as a unified system, even when separated by immense distances. Let's break that down. You have particle A and particle B. They're created together, and their properties become linked. You send particle A to one lab, and particle B to another hundreds of kilometers away. You measure A's spin, and B's spin is instantly determined. Change how you measure A, and B's result changes. 2. Now pause. The signal didn't travel between them. No hidden wires. No energy waves. The measurement on one affected the other with no detectable communication. This isn't science fiction. This is the foundation of quantum cryptography and quantum computing technologies being built right now. So how does this relate to consciousness? Let's explore an idea that's both compelling and controversial, that the brain, or more specifically the mind, could operate in ways that are not limited by space or location. That conscious experience might be non-local, not entirely confined within the skull. This doesn't mean your thoughts are floating across the galaxy, but it challenges a basic assumption we hold, that everything about awareness, thought, and experience is happening only in the brain, at a fixed location in space and time. The truth is, neuroscience has yet to fully explain the mechanics of consciousness. And while the dominant view is materialist, that the brain generates consciousness through neural activity, some researchers argue that this doesn't account for everything we observe. Take studies in parapsychology. Yes, the field is heavily disputed, but some controlled experiments have suggested phenomena like telepathy, remote viewing, and mind-matter interactions occur more often than chance would allow. These results are not consistently repeatable. They're not widely accepted, but they remain intriguing, partly because there's no known mechanism to explain them, unless consciousness is in some way non-local. Now let's ground this in current scientific models. The holonomic brain theory, proposed by Carl Pribram and influenced by physicist David Bohm, suggests that the brain processes information using holographic principles. In a hologram, every part contains the whole. This model implies that memories and cognition may not be stored in localized brain regions, but distributed across interference patterns throughout the brain. This overlaps conceptually with quantum field theory, which treats particles as excitations in an underlying field. From that view, the brain might not be creating consciousness, but tuning into it like a receiver. This leads to a fascinating question. If consciousness is a field or a wave function, could two minds become entangled? Could shared experience, emotional intensity, or deep empathy link conscious states in a way similar to quantum entanglement? The evidence isn't conclusive, but experiments conducted at places like the PAIR lab at Princeton University attempted to explore this idea. Pairs of people were instructed to feel connected across distances. Small but statistically significant correlations in physiological signals and event outcomes were observed. Skeptics point to experimental flaws and their right to demand rigorous replication. But the fact that any anomaly persists at all suggests there may be mechanisms we simply don't understand yet. Even mainstream neuroscience acknowledges phenomena like the mirror neuron system, where observing another person's action activates the same neural patterns as performing the action yourself. Your brain isn't isolated. It's constantly syncing, reacting, resonating with others. This is local. But what if it's also a clue? A clue that consciousness may be more interconnected than we think. Some have proposed the idea of a collective consciousness, not metaphorically but as a literal phenomenon. Could human minds participate in a shared informational field? Could this be what entanglement points toward, not just in physics but in cognition? Again, we're in speculative territory. We must be cautious. The leap from particle entanglement to mental entanglement is enormous. And yet, we're drawn to the parallels. Because the alternative is to believe that all subjective experience, all awareness, love, memory, intuition, is confined to 1.4 kilograms of meat inside your skull. And for many scientists, that explanation just doesn't feel complete. The push toward quantum explanations isn't about replacing science with mysticism. It's about expanding the frame, asking whether the mind might operate under rules more complex and more fundamental than neurons alone. Einstein, Bohr, Heisenberg, they all wrestled with the meaning of entanglement. And while their debates focused on particles, not people, the philosophical implications were impossible to ignore. if reality at the smallest scales is non-local, if the fabric of existence allows instantaneous connection between separated entities, then consciousness, the most complex, least understood phenomenon in nature, deserves to be examined through that same lens. Here's the key point. No one has proven that minds can be entangled, but no one has proven they can't. And in science, that's all it takes to ask the next question. Could consciousness be fundamentally linked across space? Not because of energy or matter, but because of information. And if so, does individuality still mean what we think it means? Is your mind yours alone? Or is it part of something larger, something inherently connected to the minds around it? Next, we'll look at what's happening in real research, actual labs and clinical studies, where consciousness is being measured, tracked, and pushed to its limits. The results might surprise you, because the boundaries between mind, brain, and quantum behavior aren't as clear as we once believed. You can track a heartbeat, you can measure blood pressure, oxygen levels, and even brain waves. But can you measure consciousness? Not just signs of it, not just behavior, but the actual presence of awareness itself. That's the question modern science is struggling to answer. Despite all we've learned about the brain, despite all our scans, monitors, and models, we still don't know why we're aware. We don't know how neurons firing in the dark somehow produce color, sound, memory, desire, or pain. This is what philosopher David Chalmers famously called the hard problem of consciousness. It's not about how the brain functions. It's about how function becomes experience. Let's talk about what science actually says. In labs around the world, researchers are pushing into this mystery from every angle. They use tools like EEG, fMRI, and PET scans to observe brain activity in real time. They map out the default mode network, study neuroplasticity, and trace how information flows from one cortical region to another. But all of this still leaves us with a troubling gap. We can see correlations between brain activity and experience, but we still don't know the mechanism that makes those experiences possible. Some theories attempt to bridge that gap. The global workspace theory proposes that consciousness emerges when information is broadcast across a network of neural circuits. It's a useful model for understanding attention and access to memories. But it still doesn't explain why that network should feel like anything. Why should some neural activity result in a private, inner world and other activity doesn't? That's the part nobody can answer yet. Now here's where quantum theory enters the conversation again. Not as an answer, but as a possibility. Quantum systems behave in ways that challenge our traditional logic. They can remain undefined until observed. They can interact across space instantly. And some scientists believe that consciousness itself may reflect these same principles. We touched earlier on the orchestroar theory from Penrose and Hameroff. But let's take a closer look at how this intersects with real lab data. In recent years, Hameroff's team has worked to show that microtubules, the tiny structural filaments inside neurons, exhibit quantum-level properties. They've detected vibrations, coherence patterns, and energy transfers that suggest something more than just chemical activity. Critics argue that these findings don't prove quantum consciousness. And they're right, but they do hint that the biological structures inside neurons may be more sophisticated than we thought. Meanwhile, another frontier of research is exploring what happens when consciousness is altered, through meditation, psychedelics, anesthesia, or trauma. Under fMRI, people in deep meditation often show reduced activity in the default mode network, a brain system associated with self-referential thought. Interestingly, this correlates with reports of losing the sense of ego or boundary, what some call a non-dual experience. Science can measure this change in brain activity, but it still can't explain why it feels that way from the inside. Psychedelic research offers another perspective. Studies at institutions like Johns Hopkins and Imperial College London have shown that compounds like psilocybin and DMT reduce the rigidity of normal brain patterns. Under these substances, communication increases between brain regions that don't usually talk to each other. The result is a state of fluid, hyperconnected awareness, often described as mystical or transcendent. Again, we can see it happening. But what we're seeing doesn't fully explain why it happens. And here's the kicker. Some patients under anesthesia who show no outward signs of consciousness later report vivid experiences during the time they were out. How is that possible? If the brain appears to be shut down, where are those experiences coming from? These reports are rare, but they open questions about how tightly consciousness is tied to normal neural activity. Then there are near-death experiences. In some cases, people who are clinically dead, no heartbeat, no measurable brain activity, come back reporting intense, structured memories. Some recall seeing their surroundings, hearing conversations, or traveling through elaborate, symbolic environments. Skeptics chalk it up to oxygen deprivation, chemical surges, or brainstem reflexes. But again, those explanations don't fully account for the timing, clarity, or consistency of the reports. So the debate continues. To be clear, there is no consensus that consciousness exists outside the brain. But there is a growing acknowledgement that we don't fully understand what the brain is doing, or what kind of processes might be hidden from our current tools. Some scientists are now looking to information theory to help explain the puzzle. They ask, could consciousness be a fundamental feature of the universe, like space, time, or energy? This idea is reflected in integrated information theory, IIT, developed by neuroscientist Giulio Tononi. IIT proposes that consciousness arises wherever information is both integrated and differentiated enough. Not just in brains, but potentially in any system that meets those criteria. If that's true, then awareness could be a feature of the universe itself, emerging wherever complexity reaches a certain threshold. It would mean consciousness is not an accident, but a property of organized information itself. It's still a theory. It hasn't been proven, but it's gaining traction because it offers a framework that fits both physical science and lived experience. And it suggests a radical possibility that consciousness isn't a late-stage byproduct of evolution, but a built-in part of reality, like charge, mass, or gravity. So where does all of this leave us? In a strange and exciting place. We know that consciousness is real. We know that it shapes our choices, our values, and everything we care about. But we still don't know what it is, or how it arises, or how it connects to the world around us. We have models, we have data, but we don't yet have understanding. The lab can show us the effects of consciousness, can map its footprints, but the source remains hidden. And that's why some researchers believe we may be looking in the wrong place. Maybe we need a different lens. Maybe consciousness isn't a thing that arises, but a field we access. That brings us to another question, one with huge implications for how we live, think, and act. Is the so-called law of attraction just a popular myth? Or does it reflect something deeper, something rooted in how reality actually behaves at the quantum level? Let's break that open next. The law of attraction has captured global attention. Books, seminars, coaches, all promising that your thoughts can shape your reality, that what you focus on, you attract. But is this just motivational sugarcoating? Or is there something real underneath it? Let's strip away the hype. No mantras, no mood boards, no magical thinking. Instead, let's examine whether modern physics, specifically quantum theory, offers any clues about how belief and intention might influence our lives in ways that are measurable and meaningful. Let's start with a basic fact from quantum mechanics. The outcome of a quantum event is not predetermined. It exists in a range of probabilities until a measurement occurs. This is known as the wave function, a mathematical description of all the possible states a system can be in. When you observe the system, the wave function collapses. Only one possibility becomes actual. The rest vanish. Now, this collapse is what raised eyebrows among early physicists, because it implies that observation plays a role in shaping physical outcomes. Not just passively seeing them, but determining them. So how does this relate to human intention? Are thoughts the same as measurements? Not exactly, but there's an important parallel worth exploring. Consider this. Every day, your brain filters and processes billions of bits of sensory information. But what you notice, what you choose to focus on, is shaped by attention, belief, emotion, and expectation. In other words, you don't just observe reality. You select it. You decide consciously or unconsciously what gets amplified, what becomes real to you. Now let's link this to a principle in neuroscience: neuroplasticity. Your brain is always rewiring itself in response to repeated thoughts and behaviors. The more you think a thought, the easier it becomes to think it again. The stronger the emotion tied to it, the deeper the groove it cuts into your mental patterns. Eventually, it becomes automatic, second nature. So what does this mean? It means that belief isn't passive. It's active circuitry. It means that attention isn't just noticing. It's instruction. Now bring in behavior. When your beliefs shift, your actions shift. When your expectations change, your decisions follow. And when your behavior changes, your results follow. This isn't mysticism. It's measurable. It's causal. And it's repeatable. So when someone claims that they manifested a job or relationship or breakthrough, are they bending the laws of the universe? No. But they are aligning their thoughts, emotions, and behaviors in ways that optimize outcomes. They're collapsing their mental wave function into a state that supports that goal. Now let's take this deeper. In quantum theory, the wave function doesn't collapse in isolation. It's influenced by context, by the apparatus, the environment, the setup. Similarly, your outcomes in life are shaped not just by thought, but by alignment between your thoughts, your emotions, and your surroundings. This brings us to an emerging concept in quantum theory and consciousness studies: the idea of possibility fields, that in every moment, you are surrounded by a landscape of potentials, not infinite but broad, each with a different probability. And your internal state, your focus, your emotion, your certainty shifts the probability weight. Not by magic, but by changing what you pay attention to, how you interpret events, and how you respond. For example, if you're constantly thinking about failure, you're more likely to spot reasons to give up, to miss opportunities, to confirm your fears. But if your dominant thoughts are tuned toward solutions, you literally prime your brain to notice possibilities that support those solutions. You become attuned to a different slice of reality. That's not attraction in the mystical sense. That's perceptual selection and reinforced cognition. Still, some researchers believe there may be more to it. They propose that intention itself might have a subtle physical effect. Studies conducted by the Global Consciousness Project, for example, have explored whether large-scale human emotion or focus can influence random number generators. The results? Statistical anomalies have been observed during major global events. Again, the findings are not fully accepted by mainstream science, but they keep appearing, enough to prompt continued investigation. Even in controlled lab experiments, researchers like Dean Radin have tested whether focused intention can influence physical systems. Tiny, but consistent deviations have been recorded. Not proof of psychic powers, but a sign that something unusual may be happening when the mind is highly focused and emotionally engaged. Still, we must be precise. There is no conclusive scientific proof that thinking alone causes external change. But there is mounting evidence that focused thought, when combined with emotion, belief, and behavior, can significantly alter experience and outcome. So what does this mean for manifestation? It means this: when you align your thoughts, beliefs, and actions in a consistent direction, you're doing something very real. You're reprogramming your internal filters. You're influencing your environment through behavior. You're narrowing the range of probable outcomes in your favor. The law of attraction, then, isn't about wishful thinking. It's about pattern recognition, attention training, and behavioral reinforcement, all amplified by the powerful, sometimes mysterious ways your consciousness interacts with your body and your world. This is not to say that anything is possible at any moment. You can't think a mountain into moving, but you can think yourself into becoming someone who climbs it. So when physics shows us that the world exists in probabilities, and neuroscience shows us that belief systems shape perception, and psychology shows us that perception directs action, we start to see a pattern. Thoughts don't create reality. They shape access to reality. They determine which doors you see, which ones you approach, and which ones you're willing to open. That's the true science behind manifestation. And it leads to one final mind-shifting question. If your brain isn't the generator of consciousness, but a receiver of something larger, then what exactly are you tuning into? That's next. You feel your thoughts are yours, that your emotions arise from within, that your consciousness begins and ends inside your brain. But what if that isn't true? What if the brain isn't a generator, but a receiver, a transducer, a localized interface tapping into something much broader? This is not a mystical claim. It's a scientific possibility, one that's being taken increasingly seriously by physicists, neuroscientists, and philosophers. Because despite decades of effort, no model has yet explained how 1.4 kilograms of biological tissue can generate a self-aware mind. We know what parts of the brain light up when you speak, remember, feel pain, or fall in love. We know which areas are associated with vision, emotion, logic, movement. But knowing the wiring doesn't explain why it becomes an inner experience. A screen doesn't become conscious when it displays a movie. A phone doesn't feel when it transmits a voice. So perhaps consciousness doesn't emerge from the brain. It emerges through it. This idea has been explored in various forms for decades. Nobel physicist Sir Arthur Eddington suggested in the early 20th century that consciousness might be a fundamental property of the universe. More recently, models like panpsychism and integrated information theory are picking up where materialism has stalled. Let's start with panpsychism. This theory proposes that consciousness is not unique to complex brains. Instead, it is a basic feature of reality like space, mass, or energy. Every particle, every atom, may carry a tiny spark of awareness. Not thoughts, not selfhood, but the raw capacity for experience. That idea might sound wild until you consider the alternative. If consciousness is purely an emergent property of complexity, then how does it emerge at all? At what point in neural complexity does a rock become a brain? At what number of neurons does the switch flip from darkness to awareness? Panpsychism bypasses that problem by saying, awareness was always there. It's not added on, it's built in. Now consider integrated information theory, IIT, developed by neuroscientist Giulio Tononi. This theory argues that any system that integrates information in a certain way possesses some degree of consciousness. By this model, a human brain is highly conscious. A bee colony is moderately conscious. A thermostat very minimally. Again, the key insight is that consciousness isn't generated only by biology. It arises wherever there is complexity plus integration. Now here's where this gets personal. If your brain is an integrative system, and if consciousness is a property of information integration, then perhaps your mind is part of a much larger informational field, a kind of distributed awareness, a network that your brain accesses rather than creates. Think about a radio. It doesn't create the music, picks up signals that are already out there. Change the tuning and the signal changes. Remove the device and the signal still exists, it just can't be received. Some researchers believe consciousness might function in the same way, that when brain activity ceases, temporarily or permanently, the underlying field remains. This is one way to interpret some near-death experience reports, where individuals describe vivid perceptions even when brain function appears to be absent. Skeptics argue these experiences are hallucinations or final flickers of brain activity. That's possible, but some cases suggest a level of awareness and detail that challenges that explanation. Again, no definitive proof, but enough anomalies to keep the question open. Then there's the quantum brain hypothesis, suggesting that your brain may access information beyond local time and space. If true, it could explain the sometimes uncanny nature of intuition, sudden insights, or connections between people who are far apart, not as psychic phenomena, but as expressions of non-local information. No wires, no signals, just fields. The truth is, we don't yet know what consciousness is, but we know it exists, and we know it doesn't fit neatly into any current scientific box. It behaves like a field, feels unified. It changes outcomes. It defies location. So what happens if we begin thinking differently? Not just about the mind, but about identity, about life, about connection? If consciousness is fundamental, then maybe you're not just a skin-wrapped individual. Maybe you're a node, a local interface of a broader awareness that includes everyone and everything. This changes the stakes. It reframes solitude. It challenges competition. It redefines death. Because if the brain is a receiver, then death may not be an off switch. It may be a tuning out of this particular signal, but not of consciousness itself. Again, there's no proof, only models, theories, suggestions from the edges of physics, neuroscience, and philosophy. But ask yourself, why does consciousness matter to you? Because it is you. It's the source of your experience. It's what makes life meaningful: joy, grief, love, purpose. None of it matters without awareness. And that awareness, yours, is the greatest mystery science has ever faced. So as we bring this exploration to a close, consider this. Maybe the mind doesn't live in the body. Maybe the body lives in the mind. Maybe your awareness isn't locked in a skull, but stretching, reaching, participating in something infinite. Right now, we aren't here to claim final answers. We're here to ask better questions. Because questions pull us forward. They remind us we're still learning, still evolving, still tuning into a signal far greater than we can yet describe. So keep thinking, keep questioning, stay curious. Because the journey of consciousness may just be beginning.